Hello, everyone, and thank you for joining us for today's webinar hosted by our Solutions Engineering team. Today, we will discuss how to optimize your production workload deployments with Terraform Enterprise. I'd like to introduce you to our presenter today. Sean is a Solutions Engineer at HashiCorp. Sean is going to introduce Terraform Enterprise with Sentinel and demonstrate how to deploy your production workloads with maximum efficiency. Finally, Sean will give a demo and wrap up by answering questions about Terraform and Sentinel that any of y'all have. I also want to note that this webinar is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. With that, let's go ahead and get started. Take it away, Sean.
Thanks, Amanda. All right, we should be screen sharing now. Can you see the slideshow? All right, it says sharing. I'm going to assume everyone can see it. Hi, I'm Sean Carolyn, Solutions Engineer with HashiCorp. Today we're coming at you live from Houston, Texas. If you tuned in to part one of this webinar, welcome back. I missed you. Today we'll be talking about how to safely provision dev, QA, and production environments using Terraform Enterprise. Quick little intro slide. If I can get it working. There we go. I am a HashiCorp Solutions Engineer. I'm based here in Texas. Interesting fact about me, I learned to type on a manual typewriter, so got nice strong pinky fingers from that. I'm a recovering systems administrator. I enjoy building robots and automating things, and a couple of my hobbies are yoga, and I also like making pizzas. Let's have a little recap of the previous episode. In part one of this webinar, we showed you how to use Terraform to deploy a serverless application. And in that webinar, we showed you a simple tagging system that was used to mark AWS instances for deletion after their time to live expired. Hopefully you saved a ton of money and learned a bit about Terraform and AWS Lambda in the process. But how can you make sure everything gets tagged properly to begin with? In part two, today we'll show you how to securely and safely provision cloud infrastructure with Terraform Enterprise. But before we do that, let's talk about the cloud and some of the challenges of moving to the cloud. Everybody wants to move to the cloud, and infrastructure on demand sounds great. What's not to like? So the idea is you could just pay as you go, and your cloud vendor will manage all of the hardware and the low-level infrastructure for you. But it's not quite that easy. Vendors and the DevOps unicorns will tell you, hey, it's great. Just sprinkle some DevOps on there and you'll be good to go. But anyone who's actually done a cloud migration project will tell you it isn't quite that easy. If you simply lift and shift your current legacy processes and code into the cloud, you'll be a little better off, but you still won't achieve the velocity or the efficiency that you were promised. Working in cloud environments requires a shift of your mental paradigm. Instead of standing up servers and naming them and carrying and feeding for them for years at a time, we need to be prepared to provision and tear down application environments at a moment's notice. So some of the things we want to be able to do inside of cloud environments are, ensure that our organizational standards are followed correctly. We don't want folks just going off in their shadow IT organization and building things randomly without any oversight. We want to have increased control and security, reduce risk and human error, and we want to maintain an audit trail of all the changes made to dev, staging, and production environments. And that all begins with an API. This is not a real device. That's my disclaimer, my first cloud console. In the cloud, everything is an API, all the way down to the network level. You can describe entire networks and virtual data centers using code, which is pretty amazing. AWS itself is a service-oriented architecture, and every single object inside of AWS has an API endpoint that you could use to create, describe, list, and destroy each one of those things. And this goes way back to a famous memo that Jeff Bezos was said to have created in 2002. It was more or less a mandate. Every single department inside of Amazon was required now to move to a service-oriented architecture. So instead of having a backdoor or a shared spreadsheet or some sort of bespoke process for exchanging data and information between departments and teams, every one of these teams now had to be able to interact with an API. If they wanted to expose data to other departments, there had to be an API for it. And all of those APIs were mandated to be ready to be public facing right from the get-go. So these are some of the seeds of AWS. Amazon's design philosophy was that everything should work through an API, and you can't cheat or make an end run around it. You must interact through these APIs. The GUI itself is nice. Don't get me wrong. We use the web console every single day, but it's also training wheels. And if you get used to only doing things through the UI, you'll never really unlock the full power of cloud. Moreover, giving your users unrestricted console access is risky. So you might have kids, or maybe you remember being a kid, and what it feels like when you step inside an elevator. What does every little child want to do in the elevator? That's right, they want to push the button. And some kids want to push all the buttons. Now imagine you have a bunch of kids and you have to watch over all of them, and they're all in the elevator together, and every wall is coated with buttons, kind of like Charlie and the Chocolate Factory. There's an elevator in that story, and there are buttons everywhere. And you've turned your band of kids or developers loose with all of these cool buttons. Well, of course, they're going to want to push all of the buttons. This is a lot what it's like just turning people loose inside of AWS. There are a huge number of things you can build, and some of those things are very, very expensive. So it could be a little risky, and you could easily make a mess in your AWS account if you just let folks go wild on the console or the API. How do we solve for this? You have to master infrastructure as code. Instead of making manual steps and clicking buttons, we've got to get to a point where we can define all of our infrastructure in code and break that habit of using the console to create resources. I know it's easy. Amazon makes it easy on purpose because they want you to create things and leave them running. They make more money that way. What is infrastructure as code? I like to think of this as the DNA of your infrastructure. DNA is really amazing stuff. There are only 4 base pairs or base pair amino acids, and those are adenine, thymine, cytosine, and guanine. The pyrines and pyrimidines. These base units are connected together in pairs, and those pairs wrap together into long strands of the double helix. So genetic code can actually be read to build and create biological structures. Isn't that amazing? It's a biological computer. So infrastructure as code works a lot like this. Instead of putting humans on keyboards, we write code that forms the blueprints of our IT infrastructure. So in the diagram here, we have RNA polymerase, which is reading the DNA and transcribing it, and then turning it into, whatever body part or type of cell that it needs to create. It's quite an amazing process. So all the details for building out complex topologies can be encoded in a simple language. That code is meant to be both human and machine readable. So now I'm talking about actual computer code, infrastructure code now. And everything should be stored as code. We want to eliminate all of the manual instructions and steps that might slow us down or create risk of errors. Let's pivot over to the land of computer code and infrastructure as code. So there are several tools. You've probably heard of some of these various tools. These are all used for building infrastructure as code. And this particular group of tools are meant to configure your operating system. So you might have Linux or Windows or Solaris, BSD, what have you. And each one of these tools can be used to configure, different things inside your operating system. Your middleware, your application, your OS settings, all great tools. Each one of the ones on the left has an open source and a premium version. And then the native tools that come with Windows and Linux are traditionally Bash, the Bash shell, or PowerShell. Now, these are great tools. They do a very important job, and they help you to build everything that you need inside of your OS on a server or a container or a VM. But they're generally limited to working within the confines of your operating system. You can build bespoke infrastructure as code using Bash or PowerShell. I'd recommend using one of the tools on the left for configuring your OS. They're designed for that purpose and they work really well. But if we zoom out a bit, there's a whole lot of other stuff that we need to configure besides just the operating system. We're moving out now to the level of the cloud or the data center. And in the cloud, you can build everything from scratch. It's not just an operating system on a server. I can build entire networks, firewalls, serverless applications, databases as a service. There are a whole host of things. Each one of these cloud vendors has a huge list of what you can build using their platform. And each cloud platform has got its own provisioning tool that is native to that platform. So in the world of AWS, we have CloudFormation. Azure is ARM, Azure Resource Manager templates. GCP has its own tool. It's a YAML-based tool for provisioning infrastructure. Now, YAML and JSON are basically just structured data. And these languages, they aren't really languages. It's more of a data storage format, similar to XML, if you've heard of XML. And they're meant to be machine readable. JSON and YAML are both computer friendly, and your system can read that code and build infrastructure. The problem with working with YAML and JSON is that they're not as human friendly. So imagine that you've got a JSON document, and if you've ever seen one of these, it's just a pile of commas and curly braces and all sorts of nested things. Do this for fun sometime. Take a huge JSON file, have a friend go through and delete one comma from the JSON file, and that will break the whole file, and then you have to find it without using a linting tool. Oh, it can be maddening. It's frustrating to work with. The other problem with YAML and JSON, or limitation, if you will, is that it's really hard to build logic into these types of languages. If I want to say, if X, then do Y, that's quite a bit harder to do in JSON than it is in other programming languages that are built for that sort of thing. You've got to jump through some hoops or bring a templating language to your process. And the other thing is each of these tools only works on its own platform. So CloudFormation is never going to work on Azure. ARM templates won't help you over here in the AWS world. And the same story goes for Google. Terraform, on the other hand, is meant to be human friendly. It's easy to read. It's very modular. And Terraform can work across all three of these cloud platforms. So what is Terraform? I know some of you are veterans, but some folks might not have actually seen or heard of Terraform before. Terraform is a provisioning tool. And like the name implies, we're building things out of raw resources. So in this case, the raw resource is the cloud platform. And maybe we want to build something like an AWS instance. So let's walk through this simple stanza of Terraform. This is a declarative statement. It's a declarative language. So we're saying, I would like a resource. I want that resource to be of the type AWS instance, and I want to call it web. Web is the name of this resource. We're choosing the instance type or instance size here. And here's where a little bit of that dynamic code comes into play. Instead of having to specify and hard code our AMI or machine image, we're using a lookup function to look through a table of AMI images to choose the correct one for the region that we happen to be in. So if I happen to be running this in US East 1, it's going to look up the correct image that goes in that region, whereas someone else might want to spin it up in EU West 2, they'll get a different image. This is just one small example of the flexibility of Terraform. Need more than one of something? It's really easy. All you do is define the count here, and boom, you have 4 web servers. So Terraform is the DNA of your hybrid infrastructure. It's both human and machine friendly. It's easy to copy, it's easy to reuse, it's easy to test, it's easy to share and modify. And with Terraform, you can actually expose only the necessary variables to consumers. Terraform supports a producer-consumer model where you might have a small group of Terraform experts who write this code. And then you might have a much larger group of consumers who don't know so much about Terraform, but they can still use it. They can adjust a few variables and even do self-service. They could provision their own infrastructure without becoming a Terraform expert. Terraform is a lingua franca, or a trade language. It's a link language. It's meant to link all of these different platforms and cloud providers together into one common language so that your sysadmins, your developers, your operations folks can all kind of be on the same page, and you can build any infrastructure on any platform. Terraform has an open source version. You're free to download it and use it, build your own tooling around it. And we also have an enterprise version. So why would you consider Terraform Enterprise? What can Terraform Enterprise do for me? Terraform Enterprise has a couple of different modes. The one I'm going to show you today is the easy mode. This is UI integration with the version control system. So it's a simple pipeline that will help you put some checks and balances into your provisioning and safely and securely deploy changes to production environments. Terraform Enterprise is also very flexible for your advanced users. There's a full API, and you can build your own API-driven workflow with your own CI/CD pipeline. So if you have existing tools for testing and doing CI/CD testing, Terraform can be integrated with those using the API. You get centralized Terraform state management. So with every deploy or apply of Terraform, your infrastructure will be existing in a certain state, and Terraform records that state. We want to know what is the current status of our infrastructure. Terraform stores that in what we call a state file. Now, the problem with running Terraform on my laptop here, for example, is that state file is now stored locally. No one else on my team really has access to it, nor will they know if I make changes. So it's not very practical for working within groups. Terraform Enterprise solves that problem by creating a central store for the state, and that state can be locked, it can be protected so that multiple users don't accidentally overwrite it at the same time. You can use Terraform Enterprise just the same way you can with open source on multiple cloud platforms. So some workloads could be provisioned to AWS, you could put some inside your VMware, move some workloads to Azure or Google Compute. All of those things are available. Another unique feature of Terraform Enterprise is called Sentinel Policy Enforcement. Sentinel is a policy language that lets you put some guardrails around your users. Remember back to the example of the elevator and all the buttons everywhere. Well, maybe we don't want to expose all those buttons to every single developer. Maybe we just want to give them 2 or 3 buttons. Sentinel allows you to do that. Sentinel will put some guardrails, some restrictions around your users so that they're free to do what they need to do, but in a safe way and without hurting themselves. We support single sign-on with SAML, and also secure variable and API key management. This one's a huge headache, and we hear this a lot from customers. How do I manage all these keys that are all over the place now? Everybody gets a pair of keys to access the API. We don't know where those are stored. Somebody could accidentally commit them to source code or post them in a public place. And now whoever gets their hands on those keys can go ahead and log on to your cloud environment. Not an ideal situation. So we offer secure variable management that lets you keep those things safe and sound without having to hand them out to your users. And then finally, you can promote code changes safely and quickly through environments without breaking things. Let's talk a moment about Sentinel, and then we'll move into the live demo. So Sentinel is a policy enforcement language. It works with all HashiCorp products. And this one is meant to enforce tags. So back in part 1 of this webinar, we created a tagging system that had TTL and owner as part of it. And those things allow you to track the life cycle of instances and know when to delete them. So let's walk through this Sentinel here. What we're saying is, go look through my Terraform plan for anything that looks like an AWS instance, and then loop through all those instances. And then look at the tags. If those tags contain TTL and owner, we're good. If someone did this, TTL lowercase, or maybe they did owner, or maybe they did TTL and not owner, or vice versa. If every instance does not have both of these tags spelled correctly, then Sentinel will stop you from deploying that thing. So this will help you to make sure that every instance inside of your AWS account is properly tagged. You can do other things too. You can restrict the size of instances. Maybe you don't want people to spin up a Bitcoin farm inside your AWS account. You can limit the number of instances that a user can create. You can force it to run only in specific regions. So maybe you have regulatory requirements like GDPR or PCI. There are different rules and regulations that pertain to operating in different countries. So GDPR is one example. You might need to keep data within a certain geographical zone. You can do that. And enforce tagging standards, as you see in the example here. You could mandate the use of hardened images. So I could say, these are the approved blessed images that security has signed off on, and we have to use these for dev, staging, and prod. You can't go rogue and go bring your own image. And that keeps consistency throughout your environments. These are just a few examples, by the way. There are many, many more rules possible. Sentinel is designed for maximum flexibility. So you can test other things such as the time of day or the time of week that people are allowed to use this. The list goes on. So that's Sentinel. It's a key part of Terraform Enterprise. And I'll show you that in the demo here in a moment. So before we do that, just a quick walkthrough of what our workflow is going to look like so you can see how all the pieces fit together as we go through the demo. Let's start with our source code repo. And you're going to get to see my awesome art skills here. This is supposed to be the Octocat from GitHub. So here's Octocat. And give her some legs. This is our version control system. So VCS, version control system, it's the place where you store all your code. Developers are well familiar with this. Operations people, as they move to a world of infrastructure as code, we're getting used to codifying everything. Well, you need a place to store that code and collaborate on it and test it. In this case, it's the VCS, or version control system. So that's where our code is going to live. And then we have different branches of that code. So there's a master branch here. That's the thing that goes to production. So we could imagine prod is over here. And then we have a development branch too. This is dev. So development branch, master branch. And then we're going to have the cloud here. In today's example, it's AWS. In the middle, we'll put Terraform Enterprise, and then we'll have a workstation here. That's supposed to be a keyboard. Okay, so this is where our employee is working, a developer workstation. And the workflow goes something like this. We check out our source code, check out our source code from here, and then we start testing and kind of hacking on it and think about different changes that we want to do. That translates into a feature branch, okay? So feature branch is going to come out from the development branch. We'll call this feature. A branch is a copy of the code. It's safe to work on because I'm not messing with the main branch. And then once my feature branch is tested and approved, we're going to merge it back into the development branch. And you can put approvals there if you want to. As soon as that merge takes place, that's when Terraform Enterprise kicks in. So Terraform Enterprise is watching this branch, and it's going to see any changes and pull them down into a workspace. Now that those changes have been stored locally, Terraform will make a plan and see what would happen if we ran that code. And then it applies Sentinel policies before provisioning. So we're gonna go to the cloud, and right here there's a gateway. It's Sentinel. Sentinel tests must pass before we go to AWS and build dev and staging and production. So you've got all these different environments in AWS. Sentinel is the gatekeeper. Sentinel will make sure you don't do stupid things or shoot yourself in the foot when you go to AWS or any other cloud for that matter. Now, we've tested it. we've got everything working great in dev. That looks good. So these are all dev environments. We're ready to go to production. We're going to do another pull request or merge. And this time we're going from dev into prod. What's going to happen is Terraform again will see the change in a different workspace, in the prod workspace, and the same Sentinel process has to happen. Now you can also have extra approvals here as well. So you can have someone actually have to review the code and approve it before we even go up into Terraform. So that's the workflow in a nutshell. Let's go ahead and jump into the live demo. All right. So our story begins with a company called Spacely Space Sprockets. This is the world's leading manufacturer of, you guessed it, space sprockets. And they use Terraform Enterprise. So this website here was built using source code. It's stored here in GitHub in the Spacely Space Sprockets repo. We have our default master branch. That's what goes to production. And then we have a development branch where we can build and test changes without breaking prod. Here are the results over here of what we built. So right now we have 3 production machines. Those are the www, and we have 1 development environment stood up. So our story begins with the sysadmin, senior sysadmin. Let's call him George. George needs to get logged on here before he can do anything. So he's going to try to sign in here. And the first thing we see is 2-factor authentication. So this is another layer of protection you can put around your Terraform and your infrastructure. 2-factor auth requires that I have one of these nifty token generators. So I need to go in here and find the correct token for my Terraform login. Let's go ahead and put that in there. Two things. Sometimes it's called 2-factor authentication. So I need to have both something I know and something that I have. The thing that I know in this case is the username and password, and the thing that I have is a token or a cell phone with a virtual app on it. This is the first thing we see when we log in. This is the organization view. So I have an organization called Spacely Space Sprockets, and it has workspaces within it. These 2 workspaces have already been built, and those are represented by these websites here. So production, dev 1. Dev 2 and this other environment haven't been built yet. So the first thing we want to do is build a new environment. Imagine that George has got a new junior employee coming in, and he'd like to set up their dev environment before they finish their HR paperwork. It's really easy to do. If I want to kick off a manual run, I simply click Q plan here, and that will trigger a Terraform run from within the UI. The other way a run can get triggered is if you change the source code. So if I make a commit to one of these branches, that will also trigger a run. So that run is going to go through some different stages. Let's walk through those real quick, and I'll explain what each thing is doing. So the first thing it's going to do is go to a specific commit here in Git, and this is the current version of what's going to be deployed. So I can click on this and hop over to the Git repo if I want to take a look. It's pulling that code down, and then it's going to run a plan. A plan is a practice run. It's also comparing what we have in production or in development with the code we have here inside of the workspace. So do the instructions match the thing that actually got built? And Terraform is smart enough to fix parts of it. If there's one particular piece that needs to be replaced, Terraform will do that. Because the whole environment was destroyed, we need to recreate it from scratch. And that's why there are 7 things to add here. Nothing to change, nothing to destroy. We're simply provisioning a brand new environment. The next step is the policy check. These are those guardrails that I mentioned earlier. These are the checks that restrict our users. I'll show you what those are in a moment. So we passed all of our policy checks, and then finally we come down to apply. This is where the real work gets done. This is where we're actually building real resources inside of AWS. And this all happens in a very organized and efficient way. It's kind of amazing how good Terraform is at this. I want to show you something to illustrate that here. So this is a graph showing all of the stuff that needs to get built for this simple environment. And it really is pretty simple. There's one web server, and it's got a load balancer in front of it, and maybe a security group. So I'm going to zoom in a little bit to make it kind of easier to see. All right. Now, each of these has an arrow showing what its dependencies are. So you need a VPC, in other words, to have a security group. And therefore, the VPC probably should get created first. Otherwise, you wouldn't be able to make these things. I need my subdomain variable to create the security group, the target group. So what Terraform does for you is map out all of these things, quickly figure out what should be built first and what can be built in parallel, and then start standing it up for you. If I had to do this by hand, all of that logic, I've got to take into account. And this is just a simple example. Imagine if you had 40 or 50 or 100 different resources to sort together. The beauty of Terraform is it handles all that for you behind the scenes. If I look into the source code that built this thing, there are several resources in the source code. And you can put them in really any order you want. I didn't have to think too hard about what would get built first. I simply wrote the Terraform code, expressed what I wanted, and then Terraform sorts out the most efficient way to get that thing built. So it's kind of a neat process and a neat tool in that way. Okay, so we're getting to the very end of the run here. We've created this noobs environment for our new employee. And if I look at the apply out here, it says that here's the new home page. So it should be almost spun up by this point. Sometimes it's a Tomcat app, so it does take a little while to spin up. Here's a brand new environment, exactly like production. It was built almost to a T, exactly like production. The only thing that's really different here is the host name. It's an e-commerce site, and they presumably sell space sprockets. So really easy to stand up new environments. And let's call our new intern Elroy. So Elroy is really excited, and he's got his new environment set up. He would like to go ahead and play around with it too. So we've given him a login. Imagine Elroy comes and logs in, and he's looking at the variables. Now Elroy is big on testing. It's a Java app, so maybe he's running Maven. And Elroy gets this brilliant idea. If I can run, 10 tests with one machine, what if I had 40 machines? So Elroy comes in here and he wants to create 40 machines. And let's pick a size here. Let's go with the Whopper P316 extra large. This is a beast of an instance size. It's the most expensive one that Amazon offers. So these things cost around $25 an hour to run. They've got, I believe, 64 CPU cores and nearly 500 gigs of RAM. You could probably heat your house with all of the graphics cards that it takes to power this thing. So this is Elroy's grand plan. Hey, I can run all of the Maven tests in parallel on these giant instances and go home early. I hope no one from accounting is on this webinar, because this could be a $1,000 mistake if it goes wrong. Anyway, let's see, let's try it out. So hopefully, in theory, Sentinel should stop me from doing this really dumb thing. I always get nervous in this part. 79. Oh, the suspense is killing me. Oh, thank you. Thank you, Sentinel. All right, it worked. So here's the results of the Sentinel scan. You can see everything would have been tagged correctly, but we've broken two of the rules. The first rule was a hard mandatory limit on the number of instances I'm allowed to create. And then the second limit restricts the type and size of AWS instance. that I'm allowed to create. So I broke 2 rules. Sentinel thankfully stopped me in my tracks, and I wasn't able to go create a Bitcoin farm in the AWS account. So Elroy comes back. He's going to move these back to a more reasonable size and number. Let's go with the T2 medium. I think that's compliant. So there we go. That's going to plan. And you can get a high-level overview anytime you want just by hopping back into the workspaces. Workspaces can be filtered, so I can just see what's in success, what's in error. You can also filter by the run status. You've got more options hidden here in this menu here. Okay, so what's going to happen to this environment? Let's take a look. So you can see we passed the policy check now because we're not breaking any rules. Terraform is going to recreate only what it needs to recreate. So our AWS instance, I think we started with a T2 small. We're moving to a T2 medium. So you can see that's changed here. That's going and deploying. And it's going to replace it. We don't have to replace the load balancer though. That can stay. So all we're doing is swapping out the instance from behind the load balancer, standing up in a couple new ones of different sizes. So this is one simple use case for Terraform Enterprise, is standing up dev environments. You can have as many as you need. So you can see we have production here. We've got a couple of different dev environments. If you need more, it's very easy to create them. You can just click this button, or you can use the API and automate creation of workspaces as you need. Sentinel policies are created by your admins. So those are hidden in the organization settings. These are not exposed to normal users. So you can set global policies like George did here so that the junior developer like Leroy or Elroy can't make a mess of things. Okay, so that's applied. You won't see many changes because the instance basically just changed size. So that's the first part of our story. Let's move to chapter 2. So 2 weeks later, things are running smoothly, but there's a corporate takeover in the works. The news has just broken that Cogswell Cogs is buying Spacely Space Sprockets. So the usual game of musical chairs begins, and everybody's wondering what will happen with the merger. One of the things that has to happen is updating all of the corporate literature and websites and logos. That task is going to fall to Judy. Judy's a senior developer, and Judy needs to make a change to the corporate website. So Judy uses Packer, another HashiCorp tool, to build herself a new instance for testing. And we can configure that inside of the variables. So I did that beforehand. But before we do that, let's create a feature branch. You can see we're in the development branch. We're going to follow best practice and do a feature branch. Update company name. Now that we're in a feature branch, we can safely make changes and then have someone else help approve and deploy them. We'll comment out the old image, and we'll put in the new image, save our change, and then we can commit that updated company name and logo. Now I want to push this change. We're going to push it up to the VCS system. And it's telling me that the branch doesn't exist in the upstream. So we want to create that. We want to create that branch. Here's the tricky bit. I need to get my token. Hang tight 1 sec. No peeky. I'm going to change that after the webinar. All right, so the username and the password. Okay, good, paste. Nope. All right, we'll just do it from the command line. Sometimes it's a little picky. Let's try it one more time. I think my copy paste didn't work quite right. Paste. Okay, give it one more shot. There we go. I guess I fat fingered it. All right, so now I should see a new branch appear here. And it's called update company name. I'm going to create a pull request, which is a request for a coworker or a team member to come and take a look at the changes. Please review this. Yes, update. Okay, so, oh, wait a minute, I just committed to master. Okay, I shouldn't have done that. Let's go ahead and create a new pull request, and we'll go to development instead. Now, the good news is I didn't commit to master. You can't actually do that, so I can throw that commit away. We're going to fix this and do it to development. So we want to do update company name is going to go into the development branch. That's better. Please review and approve. Much better. Okay. So this one is running some checks. We're making sure that Terraform command is, Terraform plan command is actually working correctly. We don't want to push broken code out there into production. I'm going to ask my coworker, Jake, if you don't mind, Jake, could you come look at pull request number 24 to merge update company name into development here?
Yeah, sure, I can help you with that, Sean.
Thank you, Jake. So best practice is not to merge your own pull request. I theoretically could here, but we're going to follow the rules and let Jake do the honors.
I'm not sure that I'm actually in as a reviewer. I see the merge, but I don't actually see a review button.
Okay, everybody pretend Jake pushed this button.
Push the button. Or I can merge it for you if you'd like.
There we go. Okay, so that's the process, though. You get your coworker, get your trusted, compadre to come and update or merge the change in. Now we've merged into development. And here's that bad pull request that I created. Why don't we just discard this one, okay? Because in this environment, you're not allowed to merge to master. Sean did a no. We're just going to close it out. Okay, so let's leave that alone. Now we'll go back over to the development branch and see what happened. So development just got a change. It was merged. Terraform has already picked it up. So note that all three of my dev environments are now applying that change and working through it, but prod has not been changed. That's for you sysadmins out there. Is this thing safe? Can you set it up in a way that you keep the devs and their sticky fingers out of production? Yes, the answer is yes. So prod has been left alone. All three of these are rebuilding. Let's hop into one and we'll kind of look at the process. So kind of similar to the one we rebuilt earlier, we are replacing the AMI, or the machine image. This is the master image that's used to deploy our infrastructure, with the brand new one that Judy built. That takes a moment to run. While that runs, let's talk about some other features of Terraform Enterprise. What happens if I queue another plan right on top of this one? Aha, okay, so I'm locked from making changes. And Terraform is kind enough to tell me, hey, there's another run in progress. You probably want to wait till this thing is finished before you go running another one. Now, you can override that. Not recommended, but if things are stuck or it's a really long running thing, you might want to cancel. That's another thing you can do here in Terraform Enterprise. So let's Let's see if we can cancel one before it finishes. This needs to be redeployed, or what have you. So it'll try to gracefully kill that run and fix up the state before you move on to the next Terraform run. Again, back in the world of the workspace view, I can see the noobs environment is updated. So if we actually, let's go back to the home page and reload. Okay, corporate branding has been completed. So now Cogswell Cogs is in place and the shopping cart looks good. At this point, you'd probably run a bunch of tests. You want to make sure that everything is working correctly, that all your changes propagated, that nothing broke in the process. Get your UI, UX folks to sign off on it. There's a whole lot more you could do in the real world. This is just a simple example to show you what's possible. Now, Dev 2 looks to be in kind of an unknown state, and that's fine because we canceled it, right? So halfway through the destroy, it looks like it was canceled. That's left in a different state. And if we go back to prod hasn't been changed at all. So the title of the webinar is Provision to Production. It wouldn't be fair of me not to do that. So let's do that right now. We're going to do one more change in Provision to Production. We're going to get back down on the command line here. Check out the development branch, pull all the latest changes. Okay, now we're going to, actually we don't even need to pull. We can do the pull request right from GitHub. There's a handy button for that, compare and pull request. And we'll say company name and logo update. These have been tested in dev and QA. Another pull request. So the first pull request was feature branch into development branch. This pull request is going from development now into production. And this is the part that I mentioned where the review is required. This is the required one right here. So Terraform plan is going to run to make sure one last time that we don't do something that's going to break our production deployment. I think Jake could do this. Jake, you want to give it one more try? See if you can come in here.
Yeah, I actually saw the reviewers process, so I went through and reviewed.
Oh, sweet. Thanks for the review. Now I have admin superpowers. I could merge this, and you can turn that off too. That's a GitHub setting, so you can make even administrators follow the rules. Oh, okay, there it goes. All right, no conflicts. Jake has got everything squared up. Jake's going to carefully review all my code in about 10 seconds.
Yeah, I'll let you do the merge.
You let me? Oh, thank you.
Yeah, it's far more exciting if you do the merge than me, I bet.
I told you earlier, I love pushing buttons. Okay, here we go.
Yeah, don't we all?
Yeah. All right, cool. We push the merge button. Now this time, we can see only production has picked up the change that had to flow through dev and a couple stages of approvals first. So while that runs, we'll just kind of recap, and then we'll take some questions here. So to recap everything that you saw today, some of the different features, we used Terraform Enterprise to reduce risk, to become more efficient, to deploy infrastructure faster. We showed you how to put some guardrails around your users, how to eliminate unidentified resources running in your account, how to create development environments on demand, and how to have some safeguards on all your important deployment actions. So that brings us to the end of the live demo. I'll show the production website once it's done applying. Let's go ahead and open up for some questions.
Yeah, Sean, this is Brett. There's a couple questions out there I'll read for you.
Oh, great. Thank you, Brett.
Here's the first question. It says, when you say change in the code, is it application code / written in Python, C, Java, etc., or Terraform code?
It can be. So Terraform is not something you'd use to configure your application code per se, right? Terraform stands up all of the big pieces like the OS, like the entire instance. The good news is Terraform has provisioners that can run and trigger things inside of the OS that can deploy those things. So Terraform and Chef together, Terraform and Puppet, for example, where Terraform would stand up the base OS image, and that OS may be pre-configured or not. And then Terraform triggers a Chef or Puppet or Ansible run inside your OS, and then that will go ahead and finish building out your application. So it can do both in a sense, that you can stand up your OS and then pull in either Bash or PowerShell or Chef or another tool to finish the OS config. And so Terraform can work with either pre-baked machine images, or you can take stock images and then use one of those tools to go ahead and finish the build. And each of those things should be tested in their own, their own pipeline, if you will. You might even have something that just stood up one instance and did integration tests on your application.
Cool. Here's the second question.
Okay.
Is this GUI for TFE equivalent to the Terraform files, which we can write from CLI?
It's using those files. It's doing the exact same thing that you'd do on the command line. So, for example, if I ran a Terraform plan here on the command line, and I want 3 e-commerce servers, and it's going to pull those variables in. So what I just did is the equivalent of coming into TFE and let's just say here, pushing qplan. Now you can interact with Terraform Enterprise on the command line as well. I think I've got that bookmarked here. There's a command line TFE CLI that you can use to remotely interact with a Terraform Enterprise workspace. The other way you can interact with a remote workspace is through the API. So we have a fully documented, powerful API, lots of different things you can do and customizations you can make on the back end.
Got it. All right, this is a good one. Can you do integration tests for every pull request, i.e. spin up testing infrastructure, run some verification, and then tear down the infrastructure or auto destroy?
Yes, you can. You'd need to do a little bit of coding to make that happen. So you'd want to bring in a CI tool, CI/CD tool, and then what you can do is call these different API calls here. So for an automated destroy, for example, let's see, there's the API. You could do that via one of these endpoints here. Any others?
Yeah.
Okay.
How about this one? We got a few. We're going to try to get to them all, but we got a few here.
Okay.
How can Terraform Enterprise integrate or create notifications to application deployment pipelines? Often infra deploy and app deploy are two different processes unless the team is mature to do a rollout for the latest and greatest app architecture.
Infra and app are in separate processes. How can Terraform fit into that world? That's kind of what I'm hearing. All right, so we can address that. Use each tool where it's appropriate, right? If you've got a great application deployment and testing tool, you don't necessarily have to change that. Ideally, that tool is also API driven, so that in your CI/CD workflows, you could say, use Terraform to stand up infrastructure, and then pull in the application testing tool to do the app testing on top of that environment, which may be long running or short running. If the environment takes a really, really long time to build, you might leave it up and running for a while, build it with Terraform, and then use your application testing framework inside of that environment.
Okay. All right, this one's going to make you earn your money.
Oh boy, stump the SE.
Why is Terraform a better tool than native provisioning and Ansible, Chef, etc.?
Great question. They're actually different tools. So Terraform will stand up an instance like these instances here. Okay, so we can refresh. All of these things were created with Terraform. But that's not the whole puzzle. You still have to configure these machines somehow or some way. We recommend using our tool Packer. So you can actually use Chef and Terraform together, or Puppet and Terraform together with this tool Packer. And what Packer will do is take your Chef recipes, apply them inside of an instance, and it can snapshot that into an image for you. The whole reason we're able to do a demo like this inside of an hour is because of pre-baked images. So if you think of a great cooking show, they always cut to commercial and come out with a beautiful cake and say, oh, look, there's this cake. We all know the cake didn't take 3 minutes to build, but you can cheat a bit by pre-baking all of the important parts into your OS image. And so I wouldn't say the choice is Terraform or Chef or Puppet. It works better if you use Terraform and Chef.
Right. Okay, maybe one or two more?
Sure.
This is a good one. Does Terraform Enterprise support custom providers?
I'd love to dive deeper, but I can't. There's 200 of you out there, so I don't know who asked the question. Yeah. I'm going to assume that you meant custom providers for different types of infrastructure. Like maybe you're standing up something like a physical load balancer or even bare metal. We've seen people do bare metal. The short answer is yes, we do support custom providers. If you can run it in Terraform, you can run it yourself within the Terraform Enterprise.
Yep. Does Terraform Enterprise have to be cloud hosted with a cloud hosted repo, or can it be self-hosted for super secret code?
Good question. The answer is yes. Terraform Enterprise comes in 2 flavors. There's a SaaS option where we host it for you. And you obviously use private repositories and encryption to make sure everything is safe and secure. You can also do an on-prem installation of Terraform Enterprise where you stand it up inside your own firewall or inside your own cloud environment. And you can also use what we call a private module registry. So that's a bunch of bits of reusable code that you can use, all private to your own organization and heavily locked down on your own infrastructure. So the answer is yes, we can do both.
Great. Amanda, it's down to the bottom of the hour, so I guess, or the top of the hour, I suppose. So I'll turn it back over to you.
Okay, thank you. Thanks for taking over the questions, Brett. And thank you, Sean. Those were really great questions from the audience. I hope everyone enjoyed today's webinar and you're able to learn a bit more about Terraform and Sentinel. Thank you for joining, and a very special thank you to Sean for his time today. And finally, as I mentioned at the beginning, this webinar was recorded and we will make the recording available on our website after processing. I'll send an email out to everyone who registered with the recording link. I'll also include the link to the part 1 that Sean did that he mentioned in that same email. You can keep your eyes out on Twitter for the recording as well. I usually post it on there a little later today or tomorrow. So thank you, everyone, and have a great day. Goodbye.